If you want to improve a knowledge point, the mindset is actually simple. Look at it from different angles, understand it, and then build a deep connection with it. A connection strong enough to feel like a super link. Today, I'm sharing the next step of my old t-shirt makeover, along with some ideas from my dyeing practice. Every plant carries its own color language. The dye bars I used in my paper steam transfer project and in this video comes from the same tree, Spanish cherry. I first met this plant when I came to Malaysia. Later, from a few papers about its traditional uses, I learned that Spanish cherry contains tannins and flavonoid, and that its bark is used for brown dyeing in places like Bangladesh. With these clues, I brought Spanish cherry into my dye experiments. My working method can be summed up in one sentence: learn first, then experiment. Most plant dyes dissolve in water, so boiling is the most common extraction method. You can imagine making dye the same way you make soup. Both fresh and dried plants work. When my neighborhood trims trees, I pick up some Spanish cherry branches, take them home, and air dry them in the shade. Key steps: cut leaves and twigs into small pieces to increase the extraction surface. Dye material amount is usually measured as a percentage of fabric weight, OWF. For example, if OWF is 100% and your fabric weighs 100 grams, you need 100 grams of dye material. If you don't have a scale, you can start by estimating and improve through experience. Water ratio: dried material about 1 to 20 to 30. Fresh material about 1 to 5 to 10. For example, 200-gram dried Spanish cherry leaves need about 4 to 6 liters of water. I add a small spoon of baking soda, about 3 grams, to help release pigments. Bring it to a boil, then simmer for 30 minutes. Turn off the steam and let it set for 1 to 2 hours or longer. Filter before dyeing. Spanish cherry flowers smell wonderful. The first time I boiled the leaves, my whole room smelled like tea, and the fruits looked like tiny olives. Tie-dye is based on resist, tying, binding, twisting, or clamming to block the dye with simple tools and repeated motions. With physical pressure and barriers, you create endless combinations of positive and negative shifts. From Xinjiang's Atlas silk to Kyoto's conical sibylle, the region techniques differ, but the idea is always the same. First resist, then apply color. In my t-shirt project, I used tie-dye as a partial resist to protect the fern motifs. Process: lightly mark the resist zones with a pencil or tailor's chalk. Use nylon sewing thread. Cotton breaks easily to sew running stitches about 1 cm apart. Pull tight and arrange the folds. I framed the fern design with 2 rectangles and added a third small rectangle as a balancing point. Shape the folds into a cone and tie them at even intervals. Wrap the stitched area with intact plastic wrap so the dye cannot seam in. After finishing all resist area, move on to dyeing. In the previous video, this t-shirt had already been pre-moldened with an iron solution. Even though I rinsed it after steam transfer, some iron stayed inside the fibers. So when the thread entered the Spanish cherry dye bars, a valuable reaction happened. The stitched folds and the plastic wrap physically blocked the dye, protecting the fern motifs and the light yellow base color. Tips: cotton and linen dye best with heat 70 to 90 degrees. Improves color uptake and saturation. But too much steam or too fast dyeing can cause uneven patches. Make sure you have enough dye bars, keep the fabric fully immersed, and move it often for an even color. This time, I did a 25-minute normal dye test, slower, softer color, but very even. After dyeing, squeeze out extra liquid and place the thread into the iron molding again. I used the leftover molding from before. Inside the t-shirt, the tannins and the flower notes reacted again with the iron. The color deepened into a darker brown and became more stable. This is the heart of the plant dyeing. A molding both develops the color and fixes it by turning water-soluble pigments into insoluble compounds inside the fibers. After about 25 minutes, take it out, rinse away loose pigment and excess moldant, remove the threads, air dry and press, and the third is finished. My hope is that you learn not just a process, but the logic behind each step. This is why I make every video to teach the method, not just the result. For the second third, I used a ferrous sulfate ad oleum pre-moldant and made firm prints, but the impressions didn't come out as expected. I repaired it with steam transfer and finished with a post-moldant. Hi everybody, welcome to my channel. My name is Li Mei. I am a traveler, vlogger, and botanical artisan with 15 years experience, and I am an associate professor of fine art college in China, and I still a mother. Most of the time stay in Malaysia because my son studied here. And from today, I will try my best to use English to sharing my experience about botanical dyeing and the secrets of the eco print, and about my traveling story, the natural beauty. I hope you can enjoy my video. See you.